projectile projectile motion projectile motion. So let's start. An object is moving in xy plane. An object is moving in xy plane with velocity v velocity. Then make an angle theta. Then make an angle is theta. So this is the x and y plane, and this is the object and is going to the with v velocity, and this is a theta angle. Then this is a v component of v cos theta in the x direction, and the v component in the y direction is v sin theta. So this is a projectile motion. So we use the acceleration in the horizontal direction is the ax is the acceleration, and the vertical direction is the ay acceleration in the downward direction. So ax is the horizontal direction, acceleration is 0, and the ay is equal to minus g in the vertical direction, downward direction. Okay, so this is a v cos theta, this is a v sin theta, and this is the x direction. So is the velocity is vx, is the y direction is the velocity is vy. And motion in a xy plane, motion in xy plane with constant acceleration, motion in xy plane with, so that is the xy plane, and this is a projectile path, and this is a position of the object, that is the r and r naught. This is a position vector r naught and r. This is a displacement vector delta r. This point of object is the velocity is v naught. This is the point of object, this is the velocity is v. So the v is equal to vr. So delta r, this is a displacement vector, is equal to v naught t plus half at square. Then in the acceleration in the horizontal direction is 0, and the downward vertical direction in the acceleration is minus g. So delta r is equal to v naught t plus 1 by 2 minus g into t square. So delta r is equal to v naught t minus 1 by 2 g t square. So this is the position of the object in projectile path. Then delta r is equal to r minus r naught. This is the displacement vector, the difference of the position vector r minus r naught. So r is equal to r naught plus v naught t minus half gt square. This is the position of the object in position vector of r. So this is a xy plane, and this is a projectile path. This is object at the path. Then make an angle theta, and this is a component of velocity v cos theta in the horizontal direction and v sin theta in the vertical direction. Then x is equal to v cos theta and vy is equal to v sin theta. So first is in x direction. In x direction, So in x direction displacement, x is equal to x naught plus velocity in vx into t minus 1 by 2 gt square. In x direction, z is equal to 0 in a horizontal direction. That is, so x is equal to x naught plus vxt and minus 0. So x is equal to x naught plus v x into t. This is the displacement in a x direction of object. Then second is in y direction. Second is in y direction displacement of the object. Y is equal to y naught plus vy t minus 1 बटा 2 gt square. So this is a y component of the object and travel in projectile path. So next, Vx is equal to V cos theta and Vy is equal to V sin theta, the component of the velocity and x and y direction. So x is equal to x naught plus V cos theta into t and y is equal to y naught plus V sin theta into t minus 1 बटा 2 gt square. This is the displacement equation of the particle in the projectile motion. So first is equal to velocity in x direction. Velocity in x direction dx by dt is equal to 0 plus v cos theta in x direction of velocity, and second is velocity in y direction. So dy by dt is equal to 0 plus v sin theta minus gt. This is the velocity in y direction. This is the velocity in x direction. This is the velocity in y direction. Equation number 1 and equation number 2. So first is path of projectile motion. Path of the projectile motion. Path of the projectile motion. This is the xy plane. This is the xy plane, and this is the projectile path, and this is the velocity of the object, and v cos theta and v sin theta is the component of the velocity in x and y plane. So x is equal to v cos theta into t and y is equal to v sin theta minus 1 by 2 gt square. So equation number 1 and equation number 2. So value of equation number 1, t is equal to x upon v cos theta. So put in the equation number second, y is equal to v sin theta into x upon v cos theta minus 1 upon 2 g x upon v cos theta का whole square. This is a path of the projectile motion, this equation. So y is equal to x tan theta minus z upon 2v square cos square theta into x square. So this is the equation of projectile motion, path of the projectile motion. So path of the projectile motion. और सिंप्लीफाइड लिख सकते हैं इसको y is equal to minus z upon 2v square cos square theta into x square plus tan theta into x. maximum height of projectile motion. Maximum height of projectile motion. So draw the xy plane. This is the x direction, this is a y direction. यानी xy plane में अपन को projectile motion को show करना है. This is a projectile motion and this is a v velocity of the object and this is a vx direction, this is a vy direction. This is a vx velocity in x direction, this is a vy in the y direction. This point is the maximum point. I only have the vx direction velocity and this is a vx, this is a vy and this is a vy direction of velocity, this is a vx direction of velocity. So we can say at the point, P, so we can say the point P have a only x direction velocity. So we can say point P have a only x direction velocity vx. So vy is equal to 0 at the P point. So vy is equal to v sin theta minus gt is equal to 0 at the P point. So at the P point, point P have a maximum time for the maximum height. यानी P पॉइंट पे मैक्सिमम टाइम होता है फॉर मैक्सिमम हाइट के लिए, क्योंकि यहाँ पे मैक्सिमम हाइट गेन करता है एट द P पॉइंट. सो T मैक्सिमम इज इक्वल टू V sin थीटा अपॉन G. P पॉइंट पे मैक्सिमम हाइट होती है HM. So this is a maximum height. Then y is equal to HM is equal to V sin theta into T maximum minus 1 by 2 g t maximum का square. So hm is equal to, yeah, h maximum is equal to v sin theta. Put the value t maximum in this equation to v sin theta upon g minus 1 by 2 g v sin theta upon g का whole square. Then v sin theta upon into v sin theta upon g is the common, so take a common v sin theta का whole square upon g is the common, and the 1 minus 1 by 2 into z, एक और g बचेगा v sin theta upon g का whole square में से is the 1 by z, so cancel out z to g. So 1 minus 1 by 2 is equal to 1 by 2. So 1 minus 1 by 2 is equal to 1 by 2. 1 by 2 into v square sin square theta upon g. This is the maximum height of the object in projectile motion. This is the maximum height of the object in projectile motion. So h maximum is equal to 1 by 2 v square sin square upon g. Next find out total time period, total time of flying of object in projectile motion. Total time of flying of object in projectile motion. This is the x direction, this is the y direction in xy plane, and this is the projectile motion of the object. This is the point P, is the maximum height point, hm, yeah, h maximum. So an object is moving in the x direction, so the object is moving in x direction. For this is the range of the maximum range. The maximum gain the range in horizontal direction of the object, his initial position to the final position. So this is the x direction. So we can say an object is going in x direction. We can say an object is going in x direction for a range, so that for a range initial position to the final position, so that y component is 0. So y is equal to 0. Then y is equal to v sin theta into tf minus 1 by 2 g tf का whole square. tf is the time of flying. tf is the time of flying. So next, z0 for the y, and is equal to v sin theta into tf minus 1 by 2 z tf का whole square. tf gtf upon 2 is equal to v sin theta. So tf is equal to 2v sin theta upon g. This is the total time of flying. This is time of flying of object in the projectile motion. Is the projectile motion. So next trick is the find out the total time of flying in the projectile motion is the t is the maximum. T is the maximum for the half part of the projectile motion for the maximum height, and the remaining half part of the projectile motion for the ground part. So T maximum is equal to V sine theta upon G for the maximum height. Okay, and there is a half part for the ground. T no, this is a TF. TF is equal to 2 T maximum upon 2 maximum is equal to TF for the total time of flying is equal to 2 T maximum. So TF, this is the flying time of the object, 2 T maximum is equal to TF is equal to 2 V sine theta upon G. This is a trick, half part of the projectile motion. This is the half part of the projectile motion. This is the first part of the T maximum is equal to V sine theta upon G. This is TF is equal to 2 T maximum. Horizontal range of projectile motion. Horizontal range of projectile motion is equal to, this is the XY plane. This is the object for going to the projectile motion. This is a projectile path. This is a range for the object in projectile motion. This is a horizontal range. This is a horizontal range. This is the maximum height. This is the maximum height. So this is the point for the maximum point for the height, and this is the projectile path, and this is the time. F is the flying time. It is a flying time TF. So range is denoted in the x direction. No use y direction. So x is equal to v cos theta into tf. So x is denoted by the r for the range. So range is equal to v cos theta into 2v sin theta upon g, because the tf is equal to 2v sin theta upon z. So r is equal to v square 2v square sin theta into cos theta upon z. So r is equal to v square कोष्टक में sin theta cos theta, so upon z. So r is equal to v square sin 2 theta upon z for the range of the projectile motion, because sin 2 sin theta cos theta is equal to sin 2 theta. This is the mathematically expression for the trigonometry. So first for the maximum range. So put the theta is equal to 45-degree angle. So this is a x and this is a y direction. This is the value. Theta is equal to 45-degree. Make an angle with the x direction. And the r maximum is equal to v square sine 2 into 45-degree upon g. So r maximum So R maximum is equal to V square upon Z for the R maximum, because sine 90 is equal to 1.